So I will start sharing my screen. Okay, so COVID-19 myths and facts. So we'll go through, and at the end we'll have an interesting question and answer session for further clarification of any doubts or issues. Okay, so we'll start with the question: is COVID-19 a crisis or not? So this screenshot from Worldometer. You must have seen again and again this Worldometer statistics, one of the reliable statistics that we can get from the net. So around 14.5 million cases currently infected. Out of that 14.5 million, we have 99.44% mild. That means they don't need in-ward care, they don't need ICU care, they don't need even nothing. They are mild, okay? And 0.6% need serious or critical condition. So they need hospital care, maybe ICU care, they need oxygen, they need more monitoring, they require us. So that is 0.6%. With this context, 99.4% mild infection, nothing needed, 0.6% severe critical needed ICU or oxygen or whatever way of monitoring. Right? So with this context, what do you think? COVID-19 a crisis or not? Use the chat box. Can you all quickly type yes or no? Crisis, if you think it's a crisis with this context, put yes. If you think crisis with this context, put no. We just want to see. More and more answer we need. Many putting it as yes, many putting it as yes. Many more putting it as, very few put it as no, many more putting it as yes. Okay, so the majority putting it as yes, but still I cannot understand. 99.4% mild infection doesn't need anything. 0.6% only needs care. So with this context, we cannot say it's a crisis. To decide it as a crisis, we need another important information. So when you consider this number, so if you think it as 0.6%, actually it's not a crisis, really speaking. 0.6% of whatever the infection is just causing serious condition in around 0.6%. That means less than 1%. You don't need to worry much. But the problem is the number here, 92,020 people at a time in critical care, require critical care all over the world. The world is not tolerating. So that is where the number is important. It's a number game. Right? So all our focusing is to reduce that number. So the illness is not fatal. It doesn't cause much problems to majority of people who are getting the infection. But that particular 0.6%, with this 15 million, 0.6%, the count is the number 92,000. So that is unbearable. So that idea, you need to get it clearly. Okay, we'll move forward. So started with this origin of COVID. Many people have many doubts and even after the WHO team visited China, inquired about things and found out, still having queries. There are a lot of politics in it, but I'm not going to touch anything about it. But with the scientific knowledge up to now we have some idea, and we can tell that, okay, most likely this is the reason. Because so bats. Right, again, bats. So they harbor a lot of coronaviruses. That's different types of coronaviruses they harbor. So what happens that at any time point, it can cross-species transmission can occur. Right? So that is called spillover event. So when it's circulating into the wild animals in the bats population, at any point where the animals and people come together, like live wet markets, animals in live wet markets, or in any other intermediate animals, like MERS we got through bats, camel, and human. Like any intermediate animals can play a role. Then ultimately human get it through zoonotic transmission. Once it has come to our human beings, into the human population, then we don't need to get the animal, the original animal, to get the disease. Then it's circulating among us, right? So here, whenever the person contracts the virus and it has got adapted to human beings, then it circulates here because we have lots of traveling from east to west. And then there are a lot of community events which promotes transmission, and we have hospitals, critically ill patients, healthcare associated transmissions to the staff. So we all know that. So that can happen. So when we move towards, so then it's another thing that I want to say, that yes, the coronavirus, they belong to the bats, and then when it jumps to other species through another animal or directly to the human beings, then it's adapted. So the same thing happened in 2009 pandemic with H1N1, where the avian virus and the human virus together infected the pigs. Those are the mixing vessel hypothesis called the pigs. The pig cells have different cell receptors which can accommodate at a single time human virus as well as the bird avian flu virus. So then it mixed together and it reassorted, and it has produced a novel virus that caused the H1N1 swine flu pandemic, novel pandemic in 2009. So similar thing we can tell may have happened here as well, the reassortment of the coronavirus, that coronavirus, which has become adapted to human being, successfully adapted to human beings. So it's one of the theories, and it is proven for flu, and we can guess, yes, the similar thing could have happened here as well, right? So now we move on to another, this article is a very interesting article. So this was published in 2019 September, 3-4 months before the origin of COVID-19. It is a study done in rural China, southern China. So human-animal interactions and bat coronavirus spillover potential among rural residents. So an important study. And they have identified, yes, there is a chance of that they have detected seroprevalence in rural population against this bat coronavirus. That indicates that there's a spillover event occurred. And they suggested these findings can be used to support targeted biological behavioral surveillance in high-risk geographic areas in order to reduce the risk of zoonotic disease emergence. Right? So no one bothered. So until massive damage occurred, people do not bother or hear or concern about things that the scientists tell. So it's another good example. So they studied and they proved and they told, yes, although it's a low rate, that the seroprevalence is low rate, but there is a risk. So that's why they just again pointed out this risk. So be careful. We may get this zoonotic disease emergence. Right? So that spillover event is very likely. So now we we will focus on modes of transmission of SARS-CoV. All know, but still again I want to have another quick thing. So infected individual coughs, sneeze, talks, sings, laughs, shouts will develop and produce respiratory droplets in different sizes. So the majority of the droplets are more than 5 micrometer diameter, so they can't move far. They fall down with the gravity 1 to 2 meters. More than 1 to 2 meters, they cannot travel. So there are other droplets, those are the dangerous ones. So those are very small, less than 5 micrometer diameter. So they can travel more than 1 meter and circulate in the air around 20 to 30 minutes. So that is droplet nuclei. So they are the ones responsible for airborne transmission of COVID-19. Not only COVID-19, any respiratory viruses can get transmitted via this droplet nuclei through airborne. So these other larger droplets, they can have direct contact or indirect contact. So direct contact is direct touch or direct inoculation. When two people together talking and waiting, the one person is infected, then there is droplets directly go go and deposit on the other person's nose, mouth, or eye mucosa. So the direct contact, or indirect contact via the touchable surfaces, where the virus can settle down and can survive, depending on the environmental circumstances, hours, within some few minutes, or sometimes hours, depending on the environmental conditions. So indirect contact, that is called fomite transmission. So airborne droplets. So the droplets can be direct or indirect. Right? Indirect indicates the fomite transmission. So this is the modes of transmission of SARS-CoV-2. So I want to focus more on airborne transmission because it has got the attraction of following the Lancet article and the Facebook and the social media. Airborne transmission is highly likely and it's risky. Yes, airborne transmission is likely and it is risky, but where airborne transmission occurs? So airborne transmission occurs in a closed space where the recirculation of air. So people are sitting there in closed space, air conditioned, whether air conditioned or not air conditioned doesn't matter. If the air, there's no adequate ventilation comes and goes, the people has to breathe in and out in the same air. So then yes, airborne transmission is very, very, very likely. That doesn't mean you're going out in the open air, you can breathe in, you can get COVID. That is not the fact. So, but you can get COVID in an air conditioned or non-air conditioned, poorly ventilated, you are breathing and recirculated air. So then so then the droplet nuclei, that less than 5 micrometer nuclei, circulate in the air for a longer time, and anyone who comes in can inhale. That good example is if a person goes into an elevator, coughs or sneezes, or even talks to other person till he goes to the 6th floor and then goes out, another person goes in immediately, that person has quite a good risk. Right, because he has to breathe in the same air, circulating in the small lift, right? Elevator. So these are the ones, the airborne transmission. But people think if we are, when we get an intermediate care center somewhere and converting wards in hospitals, so when we are choosing a ward, so then people think if you put that ward in the middle of the hospital, then the airborne transmission, if you open the windows, the people produces respiratory droplets and it will be all over in the hospital. So it's not a case. If you are opening the windows and allow the air to come in and go out, then you are neutralizing, you are diluting the contamination. So that is the best or cost-effective way of controlling airborne transmission. Right. Okay. So R naught value. I just want to touch this again because you may have heard and you may have read in articles or social media about R naught value or RO value. So that means the basic reproductive number. So comparison of other viruses, especially other coronaviruses, the flu and Ebola. So see this H1N1 having an R naught value, a reproductive number 1.2 to 1.6 means average 1% infected, another 1 or 2% will get infected. SARS 1%, another 2 to 4%. COVID-19, if 1%, another 2 to 3%. Right? 2 to 3% can get. Ebola, look at MERS, very high, very high. So it's 1, that means it can go up to 7. It can spread up to 7, right? So the reproductive, so if you consider chickenpox or measles, 1 can go up to 10 or 15, right? So the reproductive number is very high in that viruses. So they are usually airborne viruses have higher reproductive number. They can very active transmission. So so COVID-19, luckily 2 to 2.5, yes, but still the problem is it's novel. So most of the world population is naive. So that's why it's pandemic. But it'll be soon become endemic as we have seasonal flu, right? Seasonal COVID. It soon become like that. But for the time, so this is the R naught value, the basic reproductive number, right? This is for your comparison. So Move on to the pathophysiology, very basic. So this I got it from the recent article on PMJ, that is Postgraduate Medical Journal, the part of the BMJ group, and this is a nice article. And this flow chart gives us everything about COVID-19 pathophysiology. So first, we inhale the virus. So the inhaled SARS-CoV-2 and it binds to the ciliary mucosal epithelial cells and via these ACE receptors. You must have heard this, lot of ACE receptor stories on the media, and you must have heard about this. And then the viral replication done, local propagation with limited immune response. But with that is why that 99.4% have it, right? So that's containment of virus occurs within 14 days. That's why the 14 days quarantine period. 14 days, yes, well and good, nothing will happen. But then what happens in some people, that is our 0.6%, involvement of the conducting airways, upper respiratory tract, and migration into the lower respiratory tract, and invasion and infection of the type 2 pulmonary alveolar epithelial cells, again via CV receptors. Then there are two ways happening. One, viral replication and damage of the cell, and the body's immune reaction, cytokine storm. That is the worst one. So the cytokine storm plus viral replication together causes the disease. Causes everything that we see on clinical chest X-ray. So that's the pathophysiology. So we have to stop the disease progress. We need to have antiviral and anti-immune. We don't have antiviral at the moment, so we have anti-immune drugs. So the Dexa, hydrocortisone, and this tocilizumab, the immune modulators. So all these are aiming to stop the cytokine storm or minimize cytokine storm, and that's why minimizing the damage we ourselves created to our body, overreaction of the virus, right? Overreaction against the virus. So virus itself will damage, yes, that is part of it, but the other important part is our immune response. So that happens in very few percentage of people, that is around in our, according to the current data, only about 0.6% have a consequence of severe infection due to these reactions. Right? So this is the pathophysiology. Okay. Move on to the diagnosis where we work in. So, okay, diagnosis. So I think almost 100% of the audience must have heard about the diagnosis of COVID-19. Yes, real-time reverse transcription, PCR, and rapid antigen test. So real-time reverse transcription PCR, sophisticated, a lot of attraction towards, because increasing PCR capacity is the key of controlling pandemic. That's what people believe, not that it's not really true. So PCR is a highly sensitive, highly specific, high cost, high-end diagnostic test. It's not a screening test for asymptomatic community, but even though we are using it, actually, Professor Malik Piri says that we are abusing it. We are abusing it, unfortunately. But at the beginning of the pandemic, we didn't have any other reliable diagnostic test. We had to use RT PCR. But lucky enough, in last November, Sri Lanka has got the rapid antigen test kit donated by WHO. Simple, point of care, less cost. So we'll see the comparison. RT PCR, that's the reverse transcription, real-time PCR. So that detects the viral nucleic acid in the sample. Sample, respiratory tract sample. Rapid antigen test, it detects the viral proteins, right? So viral proteins. So what's the difference? So PCR detects the nucleic acid. That means every positive PCR doesn't mean that person currently infected and infectious. It doesn't mean, because it can detect the remnants of PCR because it's so sensitive. So it can detect even the remnants of PCR. That's the very reason we don't test. Oh, sorry about it. We don't test those who have already diagnosed for the consequent 3 months. We don't test them, right? Because they will get positive results because of the remnant PCR, remnant nucleic acid, which is detected by the high sensitive RT PCR. So rapid antigen, instead of that, it detects the proteins. So the proteins, if you are to detect the proteins, then the virus should be actively there. The live virus should be there. Then only you can detect the proteins. Otherwise, you can't. So viral nucleic acid versus viral proteins. So if RT PCR positive, you can't say the patient is infectious, but rapid antigen positive, yes, the patient is infectious. Right? So sensitivity, RT PCR very high, rapid antigen lower when compared to RT PCR, around 80%, but it will pick up, its sensitivity goes up with the high viral load. So that's what we wanted. That's what we actually want, because 99.4% they don't have disease, but they have the virus. So we need to detect them. So to detect those asymptomatic people, we don't need to waste our money, energy, effort on RT PCR, but rapid antigen, the test, right? So the test. So that is the major difference. And high cost and the low cost, obviously, and the turnaround time. So RT-PCR, if we have an automated system like GeneXpert or some other systems that's also available, so they have only 2 hours turnaround time, but they don't have a high throughput, only 1 or 2 or 4 or maximum 8 samples at a time. So it's from 2 hours to days, right? When we have backlog of samples, we have reported results after 5 days, 6 days, even 7 days. Not only here, all over the world, even US, UK, PCR test results comes after 7 days. Because with that extreme, but this is the first time all the molecular lab all over the world experience such a lot of samples. This is the very first time. No, not a single example in the past as we had these molecular labs suffered like this. Right? So this is COVID, it's a characteristic. Right? So, but when you compare the turnaround time of rapid antigens, just less than 30 minutes, point of care test, then and there you get the results. So ideal for contact tracing and community screening. Right? And for RT-PCR, you need a lot of sophisticated lab staff, skilled staff, and equipment, a lot of money in it, and a lot of training, a lot of monitoring, and it's not an easy task. So when people talk and when people request for PCR machine for this hospital, PCR machine for that hospital, we need to have our own PCR machine. It's not just a machine. Machine is part of it, and a lot of training, a lot of monitoring, a lot of quality assurance things, because it's so sensitive. And if we are careless enough, you will produce more and more bad results. So PCR is not a game, right? It's a serious thing, and it's one of the best microbiological tests if it is used carefully. So PCR versus rapid antigen, yes. I'll quickly check the chat box if there is any question. Somebody has asked, and if RAT is positive and PCR negative, is it possible? Yes, it is possible, because any test can have false positive and false negative results. So rapid antigen is a point of care test, but if you don't do it properly, if you don't read it properly, you will get false positive results. And we had experiences, people get transferred from far away, putting a mark rapid antigen positive, and on admission when we test rapid antigen negative, when we call back and ask what happened, how did you all read, and they said yes, we put the sample and went for a ward rounds, came after, don't know what time, and there were 2 lines. That is not the way the rapid antigen to be. Okay, so yeah, some have asked one or twice PCR negative and they took again and it's positive. Yes, during the incubation period is 2 to 14 days. So when you collect the samples at the beginning of the incubation period, you may get negative results. And at the end of, so that's why the quarantine 14 days, at the end of exit PCR done at day 12 to day 13 or day 14 to detect the true positives. So it can happen. Yes, it can happen. Okay, so then we move on to the, what happened? Okay, so now we'll move on to why can't we eradicate COVID-19? Yes. compare with the other diseases, that Ebola viral disease. So if I hope you must have heard Ebola. So it caused around 50% case fatality, and it varied from 25 to 90% in past outbreaks. So such a bad virus, such a bad disease, it could not step out of African continent, right? Because it's not a successful pathogen. It killed around 90% of infected people. So how can the virus survive? Right? By killing everyone he infects, the virus infects. So that is not a successful pathogen. So it has on its own get controlled, but time to time it erodes there and it erupts there in African continent and not beyond the continent. We don't detect. MERS, so originated in the Middle East. Yeah, it's a Middle East respiratory syndrome coronavirus. So 35% of the people, maybe its calculation is wrong because the mild cases may have not detected in the surveillance system. So out of those who detected, 35% died. So quite high. Now see our case. Yes, this is our, again, the worldometer, but in the closed cases, 156 million cases, 98% completely recovered, just 2% died. So the 2%, the mortality rate is very low, 2%. And the more important thing is 99.4% of the infected people have only mild infection. So it's a very successful pathogen. Our body will not react to it. It's happily accept it because it doesn't cause much problem. But the problem is it at a time when it infects nearly 50 million people, we need 92,000 people in the wards, in ICU, in critical care. That is the problem. Right? So not the disease itself, but its transmissibility. Right? So this is successful. So that's why eradication is very difficult with such a successful pathogen. Right? You see the chat again and come. Okay, so we'll leave the questions to the end. Otherwise, it takes time. So we'll leave the questions to the end. Okay, thank you, Lalisha. Right. So so this is a very another reason. Oh dear. Okay. Another main reason why we cannot eradicate because of our lifestyle. We have lots of touchable surfaces. See that from banking, supermarkets, and see our classrooms. Classrooms, universities, everywhere congestion, and we don't worry about ventilation. Wherever there's places there, we put a partition, make a room, put a split AC in hospitals, in schools, and everywhere. We have this habit, like partitioning, because we want our demarcated rooms, that each one has their own room, and then we want to have that physically separated rooms, and we don't bother about the ventilation. If there's a ventilation problem, we just put a split AC. Comfortable, but not really for the virus. Comfortable for the virus too, that is the problem. So congestion. And our traveling, air traveling, you all know how congested it is, and our clinics, I don't need to explain, and our transport system, train, buses, and more importantly, our wedding halls. We want to have high-fi weddings in air-conditioned rooms, congested people. So all our parties, not only weddings, birthday parties, 1-year birthday, 1st-year birthdays, 2nd-year birthdays, every birthdays, and puberty ceremonies, everything in such closed spaces. So it's our lifestyle. So it's very difficult. It's very good for the virus, COVID-like. So it can easily get transmitted here. So it's very hard for anyone to eradicate the virus from the world because it's so adapted. So that's my point. So how do we interrupt COVID-19 transmission? Right? How do we interrupt? Right. So now we see, you all must have seen this and familiar with that. Yes, clean our hands, either soap and water or alcohol-based hand rub, cough or sneeze and tissues or bend elbows, and touching our nose and avoid touching, and limit gatherings, and avoid close contact when the person is sick, and clean and disinfect the touchable surfaces. This is a major thing, right? Plus, mask wearing. This is not, the first ones are common for flu and everything. Mask wearing, we were not that familiar. But East Asian countries were familiar because of SARS, right? SARS-CoV-1, first SARS, so they are familiar. Because this is a very effective source control measure, because by wearing the mask, so we are reducing the amount of respiratory droplets released into the environment. So it's a source control measure. The way we are wearing and the type of mask we are wearing, it's protective to the wearer as well. So that is, this is two-way, protective to the wearer as well. So the mask, that is good. So the second mask I put here, and I don't know whether you can see properly, this is kind of a filtered mask, because surgical mask doesn't have filter, it's just a physical barrier. The second type of mask is it's kind of an N95, but the problem here, why I put across is, the problem here is the filter here. So the wearer breathes through the so not the filter, it's a valve, through the valve. So that makes the wearer comfortable, but the neighbor dangerous, because his own breathing comes without any barrier. So this is not a recommended one for the public to wear. But healthcare workers can wear while handling the patients, while handling the COVID patients for a long time if they wear. So this is a good mask, because provided that they are not infected, they are handling the infected people, but they need the comfort, the wearer, so they can wear. But the public should not use this, because the public, we are telling to use the mask as a source control measure. So they have to use the mask to reduce the aerosols coming out of the environment from the wearer. So then another measure that we have to do is rapid testing at the community to rapidly detect and isolate. So if we are having a lockdown, okay, well and good, then you don't need to do the screening community. But if you don't have a lockdown and you want to have an open economy, and everything is open, then you need to have, till the pandemic ends, we need to have this kind of a testing, because asymptomatic, high viral load people can effectively spread the infection in the community. Okay, so we need to have that testing and identifying and isolating them and there. We don't need to have an institutional isolation. We can identify them at home isolation, again, feasible, and that will significantly reduce the number of cases in the community. Quarantine purpose, yes, those who are coming outside the country, because we are an island nation, so we have the facility. If we are coming outside the facility, quarantining 14 days will significantly reduce and protect us from variants from other countries. So the quarantining, yes, quarantine people, that is another important measure that we need to go ahead until we have a good control of the disease. We need that. And last but not the least, that COVID-19 vaccine. So these are the basic prevention measures of COVID, interrupt the transmission. So when we move on to the vaccine, so the types of vaccine, there are 4 major types of vaccines. So you all must have heard the Pfizer vaccine. So that is the genetic code vaccine, good example of the genetic code vaccines. The vaccine contains either mRNA or DNA of that codes for the spike proteins. So in a carrier molecule, it is inserted, and the body reacts to it, and the antibodies are produced. Okay, that's one. Viral vector vaccine, that's we all got through AstraZeneca. Viral vector vaccine, that's the Oxford, origin Oxford, and Indian product with AstraZeneca. So this is a viral vector, that's our chimpanzee dead virus, not the dead inactivated virus. Inside that, we have the genetic code for the spike proteins, and it is delivered. Or we have subunit vaccine, and a good example is hepatitis B vaccine. So this is a subunit vaccine. So only the spike protein is introduced to the body. So no, nothing else. Or now we have the Sinopharm or Sinovac, that is weakened or inactive vaccine. The COVID itself, coronavirus itself, are weakened and inactivated or killed vaccine. So that is given. So 4 types: genetic code or viral vector, subunits, or inactivated vaccine. So how it works in the body for interest sake. So got the vector ready, that whether if it is Russian Sputnik, then it's a human adenovirus, but it's not causing disease in the body, it seems. For the AstraZeneca and Oxford, there's a chimpanzee adenovirus, so it cannot multiply into our body. So that's a vector. And inside the vector, we have the genetic code inserted, and it's delivered to the body. So the body reacts to it, and the immune cells at the site of the injection will accept that genetic particle, and then it translated into the spike protein. The cells display the spike protein, T helper cells identify it, and then it stimulates the B cells, and the antibody will be produced, and the memory B cells will be preserved. So next time if the natural infection occurs, the memory B cells will be immediately triggered, and antibody response will be good and will be cleared of infection. That is the theory behind it. But the efficacy of the vaccine varies between the brand and the type of the vaccine. So, for example, AstraZeneca is around 60%. Pfizer, they say it's more than 90%. So it depends on the vaccine type and the technology used and the person who receives the vaccines, and depends on many factors. But the main purpose of vaccination is, yes, because we were naive, that's why it has become pandemic. Now we are immunizing people and making more and more people immune to the vaccine, immune to the virus. So then the transmission will be significantly less. So those who get vaccinated also get the disease. Yes, definitely also get the disease, but the chance of getting severe disease will be significantly low. So and then the transmission in the community will be significantly low. So that's the basis of this vaccination campaign in a pandemic, right? Okay. Right. Now, we know the virus is very successful. We know our lifestyle is very comfortable for the virus to spread. So are we ready to change ourselves? So considering my focus is on you all, the students. So then considering traditional large group lectures where you comfortably sleep, comfortably dream, comfortably do anything that you want in a lecture hall, or we want to have an online session for that large group session. So are we ready to change ourselves? So, but risk, benefit, advantages, disadvantages. Right. To me, I don't know what you all can learn in such an environment. Large groups, a person is talking, and some are comfortable, some are uncomfortable. 1 o'clock in the afternoon after coming from the clinical appointments in our sweaty lecture halls. Are we learning anything? I'm not sure. So if we can switch that to comfortable online mode, just think better option. Yes, COVID taught us this. Yes, better option. Okay, and then the next is this clinical appointments. What we learn and how we behave in that one person. Around 15 to 20 medical students, the consultant and the registrars, SHOs, HOs, nursing staff, board rounds and learning lessons. So that is the traditional way. That's how we also learned. That's how the consultants also learned. So that's very difficult to change. But this is the time to think and change. Are we doing the right thing? Can we have an alternative way, alternative effective way? How can we minimize the exposure risk, minimize the transmission risk in the wards? Having small groups and board rounds, how to modify the board rounds, how can we, that part, and every consultant should think about it, students should think about it, faculty should provide the ways and means. So there are a lot of things to be addressed. Right. So lot of simulation and online learning will reduce the amount of unnecessary time you spend in groups, right? So large groups or vulnerable groups. Think about it. So this is the time to change. So finally, I want to have a checklist before arranging any physical event. Ask yourselves, can we done it online or not, that event? So whatever the event you're organizing. So your first question is, can it be done online or not? First question. How many participants I'm expecting? How many participants? Can it be arranged outdoor? Again, it's a good option. Can it be arranged outdoor? Ventilation of the area, is it adequate for the number of participants? Is it openable windows present or not? Or windows and doors open into a narrow corridor or in an open space? Or how is the ventilation? Can be social distancing possible or not? So, the example of questions. So, when you are arranging a physical event in near future, you need to think all this. And before you step into another any meeting room or any area, you have to think about it. Is the windows open? How many people are there? Are they adequate? The space is adequate? How many minutes I need to spend here? Are they wearing masks? So this should come in reflex for us to handle the successful pathogen, because the virus is so successful, and so smart, and if we are not smart enough, we can easily lose the game. So one major advantage is this, because the virus is successful, that's why it's not causing severe disease in more than 99% of people who getting the infection. So using that fact, if we are minimizing the number, we will come out of this pandemic. Right? So these are the things that I want to share. So now, Lalisha, shall we look at the chat box questions and go for the quiz, or what shall we do?
Madam, if we, it won't take around take that much. I think within 15 minutes or 10 minutes, it will be over. Shall we first freshen up and go to the questions later?
Yeah, so shall we do the quiz and then go to the questions? Yes.
Yes.
Okay, Lalisha? Yep.
Yes.
Okay.
Thank you. Madam, yes, madam,
yeah.
Yes.
Yes, Lalisha, go ahead. Yeah.
Yes, before moving on to the questions in the chat box, I think it will be better if we ask if there's anyone who would like to talk, especially the doctors or any students as well.
Yeah. Anything you want to ask? Yeah. Yeah. Anyone wants to ask anything, that you can use this platform? Yes.
Ma'am, am I audible to you?
Yes. Yeah.
So we got some questions from general public to our Explorer Society FB page.
Okay.
The first question is, there is a Twitter announcement from government that people who got their first dose can put their second dose from the different type of vaccine from their previous one. So, but more countries are denying putting two different vaccines. So how can we see that statement from government?
This is from Sri Lankan government.
It's from a Twitter from a government staff or member.
Yeah, that's not an official decision. Still, the WHO also not recommended two different second dose. First and second dose should be from the same type of vaccine. So different brands, and we are not sure. We don't say that we can't say that it's not useful, but we don't know how useful it is. So that's why still there's no official decision as such. Whoever who receives AstraZeneca received the second dose as AstraZeneca. Whoever who receives Sinopharm will get Sinopharm as a second dose. That's how currently the plan is. So we are not recommending the different second dose yet.
Thank you, ma'am.
Okay.
The second question is, virologist Luke, who received Nobel Prize for his discovery for HIV virus, and he gave a statement that gone viral in the social media, that he said about mass vaccination is wrong and it will make more dangerous deadly variants and suppress our immune system for other future coming infections also. So what is your comment about this statement, ma'am?
I'm sorry, then when you read about that Nobel Prize winner, you may have come across that how controversial theories he has. So this is his own assumption, own theory. So that is not scientifically proven. So anyone can tell anything about it, because he's a Nobel Prize winner. So that was the concern. But still, the point we know is, up to now we know, is that the viral variants happen with or without vaccination. That all the variants we detected even before the mass vaccination, the UK variant, South African variant, Brazilian variant, Indian variant, all before vaccination. So mass vaccination is not the only, it's not the sole inducer of variants. Variants is the virus mutates every time it replicates, because it doesn't have the DNA proofreading mechanism, DNA or RNA proofreading mechanism. So it mutates. So with or without vaccination, it mutates. But to control this deadly pandemic, vaccination is the most important way. We cannot go away with that. So benefit risk we need to assess. So the benefit is way more than the risk that we are thinking about at this moment. So I'm not agreeing with that, and any scientific body is not yet agreeing his comments. Yeah.
Thank you.
Okay. Any other? So we'll move on to the chat box question. So then one question is the death rate is more than that of the critical percentage. Yes, that is true. But you have to carefully, that's why the statistics is very tricky. So you have to carefully, so the critical rate is calculated with the current infection. That means around 14.5 million, 0.6% critical. So death is the closed one. So that means around 150, the number is way different. The number is different. So then those who have the closed thing, that means those are recovered and all died. So in that case, it's 2%. So the mortality is around 2% up to now. But with the current infection, it is only 0.6% the critical year. But when you have a closed one, that means those who have completed the disease course, that is discharged or died, in that point, it's 2%. So the two different numbers are being calculated. So that is the difference. You go to the worldometer, then you can have a clear picture. So how they calculate the current infection and those who have closed outcome. That's why the difference. But the percentage is, it's like, yes, out of current infection, only less than 1% only need critical care. But those who have come out of the infection, 2% will die. It's quite tricky when you see it as such, but we'll sit down and think, yes, it has a meaning. Okay. So the critically, with the current infection less than 1%, but when you have when you analyze all the people who have come out of the infection plus died, then it is 2%, the death rate. Okay. It will also come down with that, like when you diagnose more and more asymptomatic cases, then death rate will go down naturally. Okay. Right. So
at the same time, madam, we encourage to for everyone to talk and ask any questions if they have.
Yes. Anyone wants? Yes. Lalisha, you're correct. Maybe you may be asking, and anyone keeping a question in mind. You can raise your hands up in the thing, or you can straight away speak. That is very welcome. Then another question here. Some people say the RT is positive and PCR is negative. Is it possible? Yeah, yes, it's. I have already explained, because of the reading error of the rat or the false positive rate, you can have that. Yes. And during the cytokine storm, is there any chances to not to have fever or not to have severe symptoms? If it is cytokine storm, then you will have severe symptoms. There's no doubt about it. No doubt about it. Cytokine storms means severe illness, severe symptoms. Okay. Anyone who wants to ask anything?
Hello, ma'am.
Yes. Yeah.
Ma'am, in the COVID-19 and vitamin D, what's the relation, ma'am? There are so many vitamin D screening for the COVID patients, ma'am.
Yeah, COVID-19 vitamin D, there's ongoing debate about vitamin D is an immunomodulator, first thing, so immunomodulator. So then COVID-19 and vitamin D, there's ongoing research and doubts and everything. So the vitamin D level in COVID-19 patients are also low. Is Mayurodhan here? I saw him. Is Mayurodhan, are you here? He's really interested in, he's doing research as well on that.
Yes,
Yes, Mayurodhan. Can you tell a bit more about it, please?
Yes, as you said, vitamin D is an immunomodulator and it has several other actions about the calcium. So theoretically, they say to maintain our good immunity, we should have adequate level of vitamin D. So vitamin D deficiency can cause very severe infection. That is the theoretical thing. So there are a lot of studies have been done and it's ongoing about vitamin D. There are a lot of evidences are there. Vitamin D deficiency can cause severe infection in COVID patients. That is the reason we are supplementing vitamin D irrespective of the reports. But see, we also have started some studies in our patients, and we don't know about the reports yet. So theoretically, yes, everyone is trying to give vitamin D supplements to all the positive cases. Thank you.
Thank you, Mayuradhan. I hope that he clarified the question. No, yeah. Anyone else?
Excuse me, madam.
Yeah.
Hello.
Yes, Varuni. Yes, go ahead. Yes, we can hear you clearly.
Yeah, madam, is there a risk of one person can, like if the person is in a closed environment with a mask, can shed the virus, and then there's a risk of airborne transmission if a second person enters the room?
If with the mask means the chance is very less, because you are reducing the amount of droplets coming out of the wearer's mouth and nose. But still it's not 100% eliminated. That's why the ventilation of the room is always important, with or without mask. But the mask wearing is a source control measure. Yes, you are reducing, you are minimizing significantly the amount of respiratory droplets coming out of the wearer. But we can't say 100% no or 100% yes to the question. Yes, there is a chance, but with the mask, the chance is less. But with that mask, with adequate ventilation, chance is very, very less. Is that clear?
Yes. Yes, madam. Thank you.
Okay. Any other questions?
Hello, madam.
Yes, yes, yes.
During cytokine storm syndrome,
Yes.
is there any chances only to have mild symptoms without having high symptoms like high fever or like that? Without having like that symptoms, only to have malaise or tiredness?
If it is cytokine storm, means you have severe symptoms. If you have that in the pathophysiology, the diagram, you see that early part, the virus is in the upper respiratory tract and only a very limited immune response. Yes, that is mild symptoms. When it goes to the lower respiratory tract and it has created a very bad cytokine storm, which is cytokine storm, that means the amount of cytokines in the blood is very high and different actions, and you will have very severe symptoms. There's no mild symptoms with cytokine storm. Okay. Is that clear?
Yes, okay, ma'am.
Okay, thank you. Any other questions?
Excuse me, ma'am. Is it safe for people with comorbidities such as diabetic mellitus, hypertension, and CKD to get vaccinated?
Of course, that is the indication. They are the ones to get vaccinated because they have higher risk of developing severe COVID. So they are the ones to be vaccinated. Priority for them, comorbidities. Yes.
Thank you, ma'am.
Thank you. Any other questions?
Also, madam, there's a question in the chat box asking about the effectiveness of wearing double masks.
Yes, yes, Dalisha, yes, I also saw that. Yes, double mask is recommended. Currently, that's newly recommended, especially from CDC. That means double mask is not wearing two surgical masks together because, surgical mask is the physical barrier. It doesn't seal your mouth and nose fully. So to overcome that problem, you have a surgical mask and on top of it, a cloth mask. So you may have seen the cloth mask that people are wearing that's nicely covering. So a surgical mask and a cloth mask, or a surgical mask with a mask fitted. You may have seen in the, there are eBay thing you can even buy, mask fitter, surgical mask and a plastic ring-like thing and with the ear loop that to fit the surgical mask with your nose and mouth. So double mask, that is either surgical mask plus a cloth mask, or a surgical mask with a mask fitter, or an N95 mask if it is all alone, or N95 mask on top of it, a surgical mask to protect the N95 mask. This is how the double mask goes. Is that clear?
Yes, madam. Yes.
So somebody have written this reading rect more than 15 minutes can cause false positive. Yes, it does. So you can't read, prolonged reading is not recommended. You have to, the person who collects the sample does the test and should read the results then and there. The prolonged reading is wrong. You mustn't do that, yes. And I saw another one that if anyone suffer from COVID-19 second time, but about the mortality and morbidity, we don't know much, but it doesn't, it's not like dengue, like first time mild infection, second time severe infection. It's not like that. It doesn't work in that way. But usually we don't know the immunity, how long it lasts through natural infection. But the current studies evaluated that is around 3 months, they have their antibodies in the body, so they won't suffer another attack of COVID within the 3 months in majority of cases. Okay. Any other questions from the audience?
There's another question saying what kind of vaccine would be recommended for patients who are on blood thinners, like
on warfarin and things, no? Yes. So this is this depends on it can be case by case and depends on various other factors too. So because of the Covishield and this Oxford AstraZeneca, they induces a platelet that's antiplatelet antibodies in the body of some people, so that was the problem. But with other vaccines like Pfizer and Moderna, with that gene coding vaccines, the risk is quite low, it seems. So but still with AstraZeneca, the risk, when you compare the risk with even OCP or smoking, the risk is low still. But when you have a mass vaccination program, then you will see adverse effects also a bit on a higher side, but you should be, it's measured. It's people who are on that kind of a medication still can have Covishield or AstraZeneca with caution. That's all to be done. Yeah.
Madam, excuse me. Yeah, initially, madam, there are like the Sinopharm vaccine, there was not enough clinical data for patients above 60, but now there's a talk again that it's again safe for this elderly group with comorbidities. Is that?
Yeah, WHO's the information sheet recently published on Sinopharm says yes, it has less data. But considering that when the technique of Sinopharm is not new, and all the adjuvants are used, all the adjuvants used in this vaccine also have been used for many other vaccines as well. And this is a inactivated vaccine. So considering all the facts, it can be given to the elderly with comorbidities. That's the current recommendation by WHO.
Thank you.
Any other questions from any other audience? Someone has asked, what is Sputnik V? Sputnik vaccine is again a viral vector vaccine, but the viral vector they used, AstraZeneca used a chimpanzee vaccine, but the Russian Sputnik, they used a human adenovirus. And they use two different types. First dose, one type of adenovirus, and second dose, one type of adenovirus. It's again another immune, to stimulate effectively the immune mechanism. Okay. Any other question, anyone?
Excuse me, ma'am.
Yes, yeah.
Hello, madam. A vaccinated person, can a vaccinated person develop viral load to spread to another person?
Of course, he or she can, because the vaccine efficacy, for example, AstraZeneca is only 60%. So 40% of people can have the disease. But the advantage is they will have mild infections rather than severe symptoms. So that's why even people with comorbidities should have vaccination, because with the vaccine they can get the virus, but their chance of getting severe infection, severe disease will be less. But so the vaccinated people, they can transmit the infection to a certain extent. Yes, that is true. So that's why we should adhere to the standard infection prevention measures even after vaccination.
Okay.
Hello, good evening, madam.
Yes, good evening. Yeah.
I have two questions, madam.
Okay.
Is there any cases reported after 2 weeks of second dose of vaccination, madam?
Of course, there are a lot. Yes, there are cases. There are cases, but all are mild cases, not severe. There are cases, yes.
Madam, excuse me,
Yeah.
am I audible?
Yes, yes, you are. Yes.
Madam, I heard there are COVID patients who are completely asymptomatic, and I myself was tested positive 14 days before, and still I don't have any symptoms. So is there a chance of getting reinfected? And also, is there a need of a vaccine for such asymptomatic patients?
Yes, it's like that. That's why the 99.4% of infected people are mild or completely asymptomatic. That's the success story of COVID, because it doesn't create problems in majority of people. That is number one. And that is the very reason the body will not produce a strong immunity against the disease, because it doesn't cause much problem for the body to react badly. So only a very few people, less than 1%, reacts badly to the virus, and because of their own reaction, they succumb to it. So with that current pandemic, and our aim of vaccination is to reduce transmission, and considering the natural immunity is not good, vaccination is recommended for those who have got natural infection. Is that clear?
Yes, madam. Thank you, ma'am. So, madam, what about the chance of getting reinfected?
You have a chance. That doesn't mean that is asymptomatic people will have more chance and symptomatic people will have less chance. We don't know that one yet. But anyone who get the vaccine, who get the infection, can get the reinfection. But usually, for the first 3 months after the initial infection, their immunity will. The studies reveal their immunity is high up, and that's why we don't test even for the next 3 months. We won't test again. So after 3 months, yes, you have a chance almost equal to the other person.
Thank you, ma'am.
Okay. Any other questions, anyone?
Madam, as the time is also considerable, shall we wind this up with this, and in the chat box now?
Yes, 9 o'clock. Yes, we need to chat box. I think I'm quickly going through. I think
yes.
There's one question about the pregnancy and the first dose. The vaccination is not contraindicated for pregnancy, and there's no contraindication, or there's no indication to postpone the pregnancy or terminate the pregnancy because of the vaccination. Any vaccine is the same. Yes.
Yes, madam. So in the chat box, I have put the link to our Facebook page, and also that in the website. Yes, that one also I have mentioned. So if there are any questions, please forward into this Facebook page. So we are in touch with that. We can forward it to madam and get any of your questions answered. So I think with the time, I think it's
we can end
better for us to conclude the session for today.
Yeah. Thank you very much, Alisha.
Yes, thank you very much, madam, on behalf of the Explorer Society, and thank you very much every one of you for joining and creating this useful and effective discussion today. We will meet again with our next webinar very soon as possible. The time permits us. Well, then have a nice day. Good night, everyone.
Okay, thank you, Vaidehi. You did with the presentation. I can see how the participants number. Lalisha, you also did a very excellent role in arranging this webinar. Especially, I love the way you did the quiz. Thank you.
Thank you, sir.
Thank you very much, my brother.